Hello and welcome. Here is the agenda for this video. We start with understanding the different parts of building an application. Next, we discuss briefly about the backend development in general. We move our discussion on history of backend development in the Java ecosystem. Then we try to realize some of the pain points with frameworks prior to Spring. Next, we bring back our discussion to the Spring framework. We briefly discuss about the different components of Spring framework. We conclude this video with a quick and easy to understand explanation of IoC and DI. This video will be somewhat theoretical, but it will surely pave the right path to kickstart your learning of the Spring framework. Please do watch till the end. I'm sure it will add great value. This video is part of a playlist on the Spring framework. Playlist is designed to progressively teach Spring concepts step by step. I have made sure the quality is super good. I do request you to visit the playlist. Link is in the description. Application development is the process of building some software solution which could be used by someone. For example, your application could be a social media app being used by a human or an API which is getting consumed by another machine. It's all about providing programmatic access, a solution to certain set of requirements. An application could be either a web-based app, a mobile-based app, or an API. Whenever there is any interaction required with a human user or there is a need for some sort of interface, we need to implement those user interfaces. Say hi to front-end development. On a very high level, front-end development is responsible for presenting the data to the end users in a readable and intuitive format. It's also responsible to access the interaction triggers, for example, submission of a form, and do something about it. So you see, the front-end development seems like acting as an intermediary between the end user and some sort of black box. That black box is the backend component of the application. If frontend is all about presentation, the backend is all about what to present. Essentially, backend systems are responsible for interpreting all the requests which are coming from the frontend and reply back with some sort of response. In order to do so, the backend system needs to do a hell lot of things. For example, process the request from UI, authenticate if the user making the request is allowed to perform the requested action or not, interact with some sort of storage layer if there is a need, facilitate the processing of business logic, and the list goes on. You see, backend has lots of things to do, and at the same time, it also needs to ensure that business logic works flawlessly. Thankfully, all the added responsibilities other than handling of the business logic follow a common pattern for both the front-end development and back-end development. These common patterns have been extracted out as frameworks. For a given programming language, there are quite a few frameworks which are used for front-end development and back-end development. Java is no exception and has plenty of frameworks aimed for the back-end development. To name a few, we have EJB, Struts, Quarkus, Micronaut, etc. And of course, we have Spring. Back-end development in Java was not always easy. If you are a seasoned professional who has worked or even heard of frameworks like EJB and Struts, I can smell the stress in your eyes. These frameworks were not easy to work with and were highly complicated. Java backend development dates back to the year 1999 when J2EE 1.2 was launched. Like Java had several versions, J2EE is a branch in the Java ecosystem which is responsible for introducing the backend development. EE stands for the Enterprise Edition. Like we had Java SE, which is a standard edition, ME, which is mobile edition, EE was another flavor which had more APIs other than the standard edition to facilitate the backend development. Please note that J2EE and its later editions such as Java EE, Jakarta EE, etc. is a specification and not the actual framework itself. EE introduced the specs for what we know as servlets, JSPs, EJB, JMS, etc. The two most common frameworks pre-Spring were EJB and Struts. Spring was released in 2004. The first version was written by Rod Johnson. Spring came into existence to simplify the complexities involved with Enterprise Edition specifications. Some consider the Spring to be competitor of EE spec. However, this is not the case. Spring is complementary to EE. Spring took some good parts of EE spec and carefully crafted to help with the complexities introduced by the EE spec. Here is what Spring borrowed from EE specs. Dependency injection. Although not a concept exclusive to J2EE, DI was implicit in J2EE through EJB components. Spring made DI a first-class citizen, providing a more explicit and flexible approach to manage object lifecycle and dependencies. Aspect-oriented programming. AOP concepts were also present in J2EE, however, in a less explicit manner. For example, interceptors in EJB. Spring adopted AOP to offer a declarative way of programming around cross-cutting concerns such as transactions and security, making these aspects easier to manage and apply. Data access objects. Spring borrowed the DAO pattern from J2EE to abstract and encapsulate all access to the data source. Spring's implementation simplified DAO uses by removing boilerplate JDBC code, providing a more straightforward and productive approach to data access. Model View Controller. Spring MVC provided an alternative to J2EE servlets and JSP for building web applications. While the concept of MVC was not new, Spring's approach was more flexible and configurable compared to the J2EE model. Here is what Spring introduced. Simplified configuration. Spring introduced a more simplified and flexible way of configuration, first with XML and later with annotations and Java config. This was a departure from the heavy and verbose XML deployment descriptors used in J2EE. Spring Boot. Spring Boot, a project within the wider Spring ecosystem, introduced a convention over configuration approach, making it possible to set up standalone production-grade applications with minimal setup. This approach significantly reduced the complexity and boilerplate code required to start new projects. Spring Data. To further simplify data access, Spring introduced Spring Data, a comprehensive data access abstraction that supports NoSQL databases, relational databases, MapReduce frameworks, and even more. This was beyond the traditional J2EE approach, focused mainly around the relational databases. Spring Cloud. Spring Cloud offers a suite of tools for building some of the common patterns in distributed systems. These were areas which were not covered in the J2EE spec, but became increasingly important with the rise of cloud computing and microservices architecture. The above list is not exhaustive, and Spring does offer more sweet stuff. Let's have a quick look on what all does current day Spring Framework offer. Upon visiting the Spring IO project section, we see this huge list of 23 projects. We will glance over a few of them quickly. Spring Boot takes an opinion-based approach of building a Spring application with target of getting it up and running as soon as possible. Spring Framework. It provides core support for dependency injection, transaction, messaging, etc. Spring Data. Consistent approach to data access for any kind of data source. Spring Cloud. It is useful in building common patterns in distributed systems. Spring Security. It has comprehensive support for implementing authentication and authorization. Spring Batch. It helps in implementing high-volume batch operations. Spring for Apache Kafka. It is an abstraction for implementing Kafka-based integrations. So you get the idea. Spring has a diverse pool of projects to help in whatever use case you may be working on. This paragraph on the Spring website puts the entire ecosystem into perspective. Inversion of control and dependency injection are two such concepts which do come up whenever we talk about the Spring framework. But please note that these concepts are generic design patterns, not something which is only present in Spring framework. Let's understand these two with a simple layman explanation. Here is the context. Let's imagine you are planning a birthday party for your friend. Think of IOC as deciding not to organize every detail of the party by yourself, but instead you decide on hiring a party planner. This planner takes over the organizing responsibilities for you. For example, booking the venue, ordering the cake, arranging entertainment, and so on. You are not controlling it directly. You handed over the control to the planner. This is like IOC in software development, where you let a framework manage parts of your application. Now for dependency injection, imagine that for the party to be successful, the planner needs several things from you. For example, a list of guests, your friend's favorite cake flavor, and the budget. Instead of planner figuring these out details on their own, you provide or inject this information directly. This ensures the planner has everything needed to organize the party without having to guess the details. In software development, this is like dependency injection, where the framework supplies the components a class needs rather than the class creating them itself. So in this party planning example, IOC is like the decision to not micromanage every aspect of the party yourself, but instead let the party planner take over. You inverted the control of party planning from yourself to the planner. DI is a technique within this setup where you ensure the planner has all the necessary information and resources they need to make the party a success. Thanks for sticking with me till last. If you haven't yet, please subscribe to my channel. I hope this video added some value. If so, please hit that like button and share with your friends. Your honest feedback in the comments is valuable to me. I regularly post informative videos on software engineering and computer science. Don't forget to hit the bell for instant updates. Take care and stay awesome.